Okay, we're looking at graphs today, and there are four main types of graphs we're going to focus on. We've got quadratic. These are anything to do with x squared in them. We've got cubic, which is any equation that has an x cubed in it. We've got reciprocal, which just means 1 over. In this case, it's 1 over x. We could actually generalize this to call this k over x if we wanted to. And finally, we've got exponential. So exponential is where x is in our exponent or in a power of something. In this case, I've used k as the constant. So let's look at quadratic first. Well, the first thing to understand is whenever we've got an equation, either a quadratic or a cubic, or it could be a quartic, the term with the highest power of x, in this case, it's this term with the highest power of x. It's always going to be the term that kind of defines the general shape of the curve. So what we can really do to understand the general shape of a quadratic, first of all, is if I give myself some axes. Well, if x is equal to 0, x squared is going to be 0, and if we times that by a, which is just some some constant, some value, we get 0 still, right? If x is 1, well, 1 squared is going to be 1. Times that by a, we get a. And so I'll just put that point there. If x is 2, then we do 2 squared and we get 4. And we'll end up with 8 times 4. So we end up with something that's like that. We could just imagine a as 1 for this to keep things simpler. And if we keep going with this, we'd get 3 squared is 9, and we keep going. We basically end up with something that looks like this. And the same happens on the other side, right? Because a negative times a negative is a positive. So -1 times -1 will give us 1. -2 times -2 will give us +4. And -3 times -3 will give us +9, and so on. So what we end up doing is we end up basically mirroring this curve around the y-axis. So that is the general shape of my x squared. If we were to introduce, say, the bx term or the plus c term, what's going to happen is this is going to maybe shift around a little bit. If we added a bx term into this, well, on the right-hand side, where x is positive, we're going to end up shifting everything up by a bit, aren't we? Because we're going to add x, or some multiple of x, onto every point. And if we look at the negative side, again, in this case, x is going to be negative. And so all we're going to be doing is we're going to be subtracting x from each point. And what we'd end up with is another graph that isn't going to look too dissimilar. It might just end up looking like that instead. So that's our quadratics, right? You don't need to read too much into it, but the general shape is what's most important. With cubics, they're fairly similar. In this case, again, let's just focus on this term for now to keep things simple. Let's just say a again is equal to 1. So we're going to have 0 cubed is just 0, 1 cubed is just 1, 2 cubed is going to be 8, 3 cubed is going to be 927, and we're already kind of shooting off the page, right? On the negative side, if x is -1, well, we're going to have -1 times -1 to get +1 times another -1, because we're doing -1 cubed. Well, -1 times -1 times -1 is going to give us -1, because minus times minus times minus gives us minus. And if we do -2 cubed, well, -2 times -2 is +4. +4 times -2 is going to be -8. And what we can see is we get this kind of weird snaky shape. -3 cubed is going to give us -27 down here somewhere. And so what we end up with is a shape that looks like that. That's our cubic shape. And again, if we were to add in, these extra terms of a squared and x and a constant, all we're going to be doing is we're going to be changing the shape slightly. We might end up with a shape that could look like that. But it's going to be the same kind of shape, right? It's going to go up and then plateau off, maybe go down and then go up again. It's going to be this kind of S-shaped curve that we always get. Reciprocals. Reciprocals are fairly easy. They're quite nice compared to quadratics and cubics. So again, I'll give myself some axes. And in this case, let's just imagine a few values of x, right? So if x is really, really tiny, well, some number, any number, over a very, very, very tiny number, it's going to give us a massive number, right? It's, if we were to divide 5 by 0.00001, we'd end up with something like 50,000. And what we get, again, let's just say k is 1 for now to keep things simple. What we can say is, as x is getting smaller and smaller and smaller, this graph is going to be shooting up off the page. Well, if x is equal to 1, or if x is equal to k, if we say k is just some unknown number, at that point there, all we're doing is k over k, or we could be doing 1 over 1 if k is 1. So 1 over 1 just gives us 1, and so we pass through that point there. And again, as we continue on down, well, as x gets much bigger, anything over a very large number gives us a very small number. And so as x gets bigger and bigger and bigger, our curve gets lower and lower and lower. So the value of each y point gets smaller. And if we look at the negative side, well, if x is negative, this whole thing is going to be the exact same copied over, but it's going to be negative because we're doing the same number as before, I've said it's a positive number here, divided by a negative number now. And so positive divided by negative gives us negative. And we end up with a curve that looks like that. Finally, our exponential graph, I'll go over a little bit onto here. So again, if we have our axes, well, let's look at what's going on here. So again, I'm going to keep things simple. Let's just say k is equal to 1. But again, it doesn't matter what k is equal to. It's just going to change the shape slightly. Well, if k is equal to 1, if x is equal to 0, anything to the 0 is just 1. Right? So when x is 0, anything to the 0 is just 1. So we always pass through 1. If, say, x is equal to, let's say x is equal to 1 now. So rather than 0, we're going to say x is equal to 1. Well, anything to the 1 is just itself, right? So, we can imagine, let's just say k, well, let's just keep it as k, right? So anything to the 1 is just itself. And so if x equals 1, our graph is going to equal k. That point there is going to be k. If x equals 2, we end up with k squared. Right, so if x equals 2, rather than k, we're going to get k squared, which could be, I don't know, if k is 2, we'll get 2 times 2 gives us 4. If x is 3, we're going to get k cubed, because it's always k to the power of x. Well, k cubed, again, if k is equal to 2 in this case, it's going to be roughly 8. Right, so we're already shooting off the page again. We're ending up here. And if we look at down on the negative side of the x-axis, if we look at, say, x is minus 1, or k to the minus 1, if you remember from the power rules, k to the minus 1 is just equal to 1 over k to the 1. This minus here just means 1 over. So we're going to end up with 1 over k here, because anything to the 1 is just 1. So we get 1 over k, or a kth. Again, if k is 2, we'll end up with 1 over 2, which is a half. If we do the same thing again, if we look at x is equal to minus 2, well, k to the minus 2, which is 1 over k to the 2. Well, 1 over 2 to the 2 is 1 over 4, or a quarter. And so when x is minus 2, we get a quarter. And we can start to see our nice exponential curve forming here, right? It's going to roughly look like that. Maybe avoid that last slightly ugly bit, but that's our rough shape of an exponential. And so we have our 4 main graphs, and the general shapes that we'd expect to get from those. Right, let's look at an example question. So in this case, we're given 6 curves, and we need to match up the equation with the curve or the graph. So we want to match up the letter of the graph with the equation. Well, let's just start off with looking at graph A. Let's start off with this one. We know from what we just did that this is looking very similar to a reciprocal, right? It's looking very similar to 1 over x, or k over x. And so I can see down here, we have k over x, right? In this case, k is 4, but we've got that same equation. In this case, let's look at C next. Well, in this case, we've got what looks like an exponential, right? It tapers down when we're to the left of the central y-axis, and it like dramatically increases when we're to the right. And so I know that C is going to be my exponential. Well, in this case, exponential is going to be here, right? That's my 2 to the x term. So I know that C is going to be that one. Let's move on to D next. So D looks a lot like that standard cubic kind of graph, right? It could be that, or it could be that. Anything that has an S shape in it is generally going to be a cubic. And so I can just find my cubic, or in this case it's here, and I know that D is going to match up with that equation. Let's look at F next. So F is our standard kind of smiley face. We always expect this when we've got a quadratic, right? So that's my standard quadratic shape of x squared, and I can shift this up and down and move it around, but it's always going to look something like this. And so I know F is going to be my quadratic, which in this case is our third equation, right? That has my x squared term in it, making it the quadratic. So that is going to be F. The last two we haven't actually covered, but they're not too tricky. This just involves knowing your sine from your cos. Well, sine is going to be E, because sine always starts at 0, and so that's going to be my sine. And cos always starts at 1, and so I know B is going to be my cos term. And that is our lesson on graphs.